Okay, this is about fixed point real numbers that we need to study before we go to the next topic, which is the floating point real number. Okay, so fixed point means this decimal point here is fixed, is not moving. Okay, not moving, it's fixed here. And as you can see, this is the integer part, just like the unsigned integer number. And this is the decimal part, or the what we call the decimal part, but written in base 2 number. Okay, as you can see, this notation f sub 2, and this side bit. Okay, so therefore we call this a sign magnitude representation. Sign magnitude representation. So the magnitude consists of the unsigned integer plus the decimal part, and the sign bit represent the sign, the positive and negative sign. Okay, so we have the unsigned integer for n bits, and we have the decimal part for m bits. Okay, and you can see subscript -1, subscript -2, subscript -3, all the way to -m. Alright, so we can convert this base 2 to base 10 number. How? We're gonna use this part, visualize this part as unsigned, as I mentioned, and the rest is the decimal part, okay, which is unsigned as well. And you can see the side bit is the exponent of this -1. Therefore, -1 to the 0 is 1, that represent the plus sign. -1 to the 1, which is -1, that represent the negative sign. Okay, so we can rewrite this one again to the integer part and the decimal part. Okay, so 2 to the -1 is 1/2 here. 2 to the -2 is 1/4. 2 to the -3 is 1/8. 2 to the -m is 1/2 to the m. Okay, and y -1, y subscript -1 can be either 0 or 1. Y subscript -2 can be either 0 or 1, just like other bits. Okay, 0 or 1. Therefore, we can look at the example here. Okay, let's start from base 10 to base 2, fixed point number, where m equals n equals 2 bits. Okay, that means the leftmost are the side bits. Okay, and this is n, this is m for 2 bits. Alright, so let's take a look. 0.75 base 10, 0.75 equals to 0.5 plus 0.25 right? So 0.5 is 1 over 2 plus 0.25, that's 1 over 4. Therefore, the integer part is 0 because it's less than 1. And you can see this bit belongs to 0.5 and this bit belongs to 0.25. Alright, so finally the psi bit is 0. Okay, so it's 0, 0.11 base 2. Cool? Let's take a look at the plus 3.00 base 10. So plus psi is, the psi bit is 0. For 3 is 11 base 2. And the decimal point say here. And 00 base 10, it belongs to 00 base 2. Okay, no decimal part. Alright. Now we combine them together as 3.75. As you can see, the negative sign is represented by this psi bit here. 3 is 11 point, decimal point. 75 is 11 base 2. Therefore, minus 3.75 is 111.11 base 2. Alright. Now let's try the opposite way. Okay, convert from base 2 fixed point to base 10. Ready? Now we want to focus on the decimal part. Okay, because the integer part is 0 in this example. Okay, and they are all positive number. Okay, therefore 0.1 here is 0.5 base 10. 0.1 here is 0.25 base 10. This one here is 0.125, which is 1 over 8. Okay, and the last bit is this number divided by 2, which is 1 over 16. Okay, so you can divide this 0.125, so it's going to be 0.0625. Okay, and if we increase one more bit, it's going to be 1 over 32. So it's going to be 0.03125. And if we increase one more bit, it's going to be 1 over 64 is this number. Okay, and if you sum them up with your calculator, it's going to be 0.9375. This is getting closer to 1.0. Okay, but less than, still less than. And if we increase one more bit here, it's going to be 0.96875. As you can see, this is 93, this is 96. So it's getting closer to 1.0, but it's still less than 1.0 base 10. Base 10. Okay, and now we increase one more bit. As you can see, it's 0.98, but earlier it was 0.96. It's getting closer to 1.0, but still less than 1.0 base 10. Okay, and you can imagine 0.1111, as many ones as you can put, it's still less than 1.0 base 10. Okay, so this is pretty much the same as 0.9999 base 10. This is base 2, but still it's still less than 1.0 base 10. Alright, I hope you understand the concept of fixed point real number. Okay.